Please take a look at the whiteboard that I've posted. We are going to go straight into arithmetic sequence and geometric sequence, first being arithmetic. So I have three different sequences available for you, and I hope you had a chance to do the Pascal's triangle and finished off at least a portion of the problem set. If anything, if you sit down for about 30 minutes, you should be able to finish it all. If you've been keeping up with the practice question, it's pretty straightforward. Helen, it's okay. Totally up to you. Okay, so let's talk. This lesson is going to be specifically for arithmetic, so you will see a very similar pattern seen in all of the examples we do, and then we're going to hash out a formula, and we're going to learn how to use the formula to solve puzzles. So some questions you're going to be asked are really straightforward. It's like, is this it? Well, no. I could word the questions, or I could give you information that could make it tricky. It's up to you to sort of use your knowledge of sequences and solve it. Okay. Here we go. We've got 3, 6, 9, 12. What would the next term, in other words, what would term 5 be, the next term? And tell me what is in fact happening between the terms as we progress in this sequence.
It would
Someone
be
help me out with that.
15, and you're adding by 3 every
Right
time.
on. Yeah. So term 5 would be 15, and I know this because from the 3, I added a 3, I added a 3, I added a 3, and I added a 3. Notice that you could have defined Tn as 3 times n, but I want to refrain from that. Everything that we're going to be doing from now on is going to start with what's my beginning number and how are we changing as we progress. Okay, so what am I starting with and how is it differing as we progress in the sequence? So if I put that as your framework, what is the equation of this sequence? From my starting value, what is happening to it?
Plus Tn minus 1.
Tn. Yeah, right on. So let's hash it out. T1 is just a 3, but T2 is I add once. T3 would be I'm adding 2 times, and T4 would be I'm adding this value of 3 times. So if you take a look, when T is 1, there's nothing. When the term number is 2, I add the value once. If term number is 3, I add the value twice. And the term number is 4, I'm adding the value 3 times. In other words, whatever the n value is, the amount of times that I'm adding is 1 under that. So putting that together, the general term would be 3 plus whatever number we're adding times n minus 1. Can we apply the same idea? Tn equals a starting number plus some difference n minus 1. Can we apply that to the next one? Someone else, tell me what the fifth term is and how we go from one number to the next. Somebody else.
You add 4 each time and start at 3.
Right. So the keyword, the difference between the two numbers, or every single, I guess, sequence of numbers is 4. And so the next number will be 19. So in this case, let me use a different color just so that we know it's a different question. Tn in this case would be a starting number, and I'm adding 4 a specific number of times. Okay. How about the next one? How about I use red here? Someone else. What is happening, progressively happening, and what would be the next term in this sequence?
The sequence there's a difference of 5
Good. But instead of adding
and
5, this time I'm subtracting 5.
subtracting,
Uh-huh.
and T5 would equal 80.
Yeah. So what we can say is, again, let me just write all this out in a very, very, annoying Mr. Kim, I understand it kind of way. Okay? Like, stop being so extra and get on with it kind of way. I want to make sure everyone's on the same page. My first term is 100. My second term is 100. I subtract it once. My third term is 100 minus the 5, because that's previous. And I subtract it another time. T4 would be 100 minus 5 minus 5. And I'm subtracting it one more time. So you can say, again, that the end value dictates how many times I'm subtracting by doing it one less than the end value. Overall, my Tn is equal to the starting value and then how many times I'm adding or subtracting like that. Okay, so that's pretty much it. This is the first sort of organized way of describing patterns. Please understand that chapters 6.1 to 6.3, everything we've done so far, we were just talking about patterns and getting, like, dipping our toes into, the different ways we can talk about patterns. Chapter 6.4 is sort of like the soft, real start of the chapter, where we formally look at how we can describe fixed patterns using a formula. The first formula is Tn equals a n minus 1 multiplied by a d. The a value is the first term. We just give it the letter A because there's a lot of different places we use this formula, and it just sort of fits that we use the letter A to start. And the D is what we would call the difference between terms in a sequence. Anytime a question refers to an arithmetic sequence, arithmetic sequence, a sequence being a set of numbers separated by commas, and arithmetic being an addition or subtraction between the two, this is the formula that they will be using. So just from reading those words in a question, you know exactly what formula is going on. Let's practice. Any questions about that before we try some practice questions? No? I don't think so. It's pretty straightforward. But again, I could be always overestimating how awesome my explanations are, so please stop me and ask me questions. So all of this is basically a blurb in case you missed the lesson or something, or you wanted a quick refresher. This lesson is on arithmetic sequence, and if you see that as the description of the question,
Can I make some rice for you or something? Or?
the
Want?
No.
yes,
You want
Oh, no, it's fine.
like chicken?
it's a special day. Oh, you guys are so funny. Claire, I'm gonna mute you, okay? Sorry. So, so when you see arithmetic sequence, you're going to be using this formula. All right, let's take a look. It's very important for you to, as practice, identify, oh, come on, my mouse. Okay, it's important that you are able to identify the A and the D. Because if you can identify A and D, you automatically have the general equation Tn, and then you can use it to find any number in the sequence you want. Here's a simple question. The first number here in the sequence is 3. So that automatically tells you that the A value is 3. Next, you can find the D value using any combo you want. Any. So just to be extra here, I'm going to show you if you chose a 7, subtract by the previous number, you get 4. If you take 11, subtract by the previous number, you get 4. If you take 15, subtract by the previous number, you get 4. You can see that the D value, the difference in the sequence is 4, positive 4. And so Tn, the general equation is the first number plus n minus 1 multiplied by 4. That's it. So you found your A using the sequence. You found your D using the sequence. You can put Tn because you know it's an arithmetic sequence. They tell you that it's arithmetic, so you know what formula to use. And with that, we're going to plug it in. T20 is 3 plus 20 minus 1 times 4. T20 is 76, 79. Done. That's essentially it. Question 1b is the exact same thing, but I try to make it tricky with fractions. It's still the same stuff. I'm going to give you a minute. Just quickly try to reproduce what we were doing here, and then we'll take it up. The back page has some trickier questions, which I'm going to show you how to deal with if you ever run into them. And that's the end of the lesson. Okay? So let's do this. Again, the question says arithmetic sequence, so you know we're dealing with this formula. I'll give you 30 seconds. Try doing what we just did on the left side. Okay. Could I draw a little line? Okay. Okay. Let's see how far you got. Again, don't fret too much about the fractions. You could always turn it into decimals for now until you feel a little bit more comfortable. Take a look. I'm gonna choose, I don't know, let's pretend I chose 3 because it seems easy. 3 is going to be subtracted by the previous term. And if you don't like the fraction, that's 3 minus a 3.5. The difference in this sequence is going to be a negative 0.5, and that's okay. Okay? Next, if we have A and we have D, automatically you should move to bam, like that. And the rest is history. Could someone quickly use their calculator and tell me what T20 would be? Let's see. Okay, I got it. I believe the answer is negative 5.5. So 4 plus negative 9.5, the answer should be negative 5.5. Any questions? That's basically the straightforward part. We're good? Okay, I'm really hoping that the silence is because this is totally easy. All right, I'm going to clear this. Let's move on to the next 2 questions. They are going to show you how the questions could be a little trickier than we see right now. But I'm also going to show you some tips and tricks on how you can deal with them. Clearing all. Number 2, determine the number of terms in the arithmetic sequence. See again, it specifies what kind of sequence we're dealing with. 5, 11, 17, 23, and then the final number is 119. Determine the number of terms means I want to know how many values are there in this sequence. If I start from 5 and I end at 119, how many numbers are here? That's what the question's asking. Okay, so let's deal with it. Even if you're not quite sure, we'll work on it from bottom up. I know that the A value is a 5. I also know that because I have 2 numbers side to side, I'm going to just choose any random number, 17. If I subtract it from the previous number, the difference is 6, which means my general equation is, I just wrote a 6 in front. You can do 6 at the end if you want to. It doesn't really matter. Yeah. Everyone with me so far?
Yes.
Yeah.
Okay. from there, I know that one of the numbers, in fact, the very last number is a 119. So I'm going to just say, okay, I don't know what term that is, but the very last term is 119, and that must be 5 plus 6 and minus 1, because I know it's an arithmetic sequence. This has to follow the same formula. So I'm going to plug it in, and if I can isolate for n, that will tell me what Tn actually is. It'll tell me what number, term number 119 is. So I'm going to do that. Subtract both sides by 5. 114, 6, and minus 1. Divide both sides by 6. 1, 9. And then add both sides by 1, 20. Therefore, term 20 is 119. There are 20 terms in this sequence. So you can start getting a little bit different, right? It's coming at a slightly different angle. It's not being straightforward. It's asking for a couple of different things. But I think you can do it. Number 3 is kind of interesting. Whoa, say again?
Why did the 19 multiplied by 1 turn to 20?
Oh, it's not multiplication. If I want to get n all alone, I actually have to add by 1. Right?
Just tweaking. My mic is just tweaking out, so I understand.
Okay, got it. All right. So there's some interesting stuff going on with number 3. Take a look. I'll warn you right now. You could do it in a logical way, or you could do it a mathematical way. Logical way, there's no problem with that. In fact, it's probably faster if you just think about it logically. But if the numbers get really weird, you may want to go back and rely on the mathematical way. And hint, hint, the mathematical way involves elimination and substitution stuff from grade 10. All right, let's try number 3 together. I want to know term 20. In an arithmetic sequence, again, arithmetic sequence, it specifies where T5 is equal to 27 and T9 is equal to 43. So if I want T20, I essentially need a general formula. Your goal is to find the general formula. How do you do it? Well, there's very little help. Normally, I would find D by getting two numbers that are right next to each other. But this one, T5 and T9 are not right next to each other. But this is where the logic comes in. How far away is T9? How many times did I have to do the pattern to get to T9?
4 times.
4 times. So T9 is basically like saying, I start with 27 and I add D, add D, add D, add D. That is equal to 43. Right? So essentially, I'm going to take this here. This is what I'm looking for. 43 equals 27 plus 4D. I have an equation with one variable. If I subtract both sides by 27, I get 16 equals 4D. And then, of course, you divide both sides by 4. My difference is 4. I'm halfway done. All I need is the A value. So I'm going to take this. I'm going to plug it back into an equation. T5, which is 27, comes from the formula A plus n minus 1D. What's nice is that we can actually fill in a lot. 27 is equal to A plus 5 minus 1 times D. So 4 times 4, that's 16. What's A? 27 minus 16, it's 11. And all that's left is to calculate what T20 is. So A is 11. Maybe I should highlight this and slow down a little bit. Okay, so we found our A and we found our D. We found our A, we found our D, and you think we might be stuck, but remember, the question gave me what my n value is. So I'm going to finish this off. A is 11, n is 20, my D is a 4. So if you plug that into the calculator, 19 times 4, 76, 87. Any questions? Because I'm about to move on to the mathematical way. All right. If there's no other questions, I'd like you to go back. I'm going to leave this formula part here because that's going to be exactly the same. Um, no, you know what? I'll just leave that. Okay. Consider this now. Using this formula that we already know, I know that T5 is 27. That also equals to A plus 5 minus 1B. I also know T9 is 43, which is A plus 9 minus 1B. So I'm going to simplify this and write 27 is equal to A plus 4D. 43 is equal to A plus 8B. Here I have two equations with two variables. Does that look familiar? Sort of. Imagine this to be x and y. This is basically a case of elimination and substitution, or elimination specifically. 27 minus a 43 gives me a negative 16. A minus A is nothing, and 4 minus 8D is negative 4D. Divide both sides by negative 4, D equals 4. And all of a sudden, I have exactly the same situation as before. From there, you do the same thing here. You plug it into any equation and you find A, and then you can find the total, the 20th term.
Does it matter which order you put the 27 and the 40, like with each equation?
Nope.
Yeah.
If you did 43 over 20, 43 minus 27, the 16 would be positive, but the negative 4 would be a positive 4 as well.
Also, I can't remember. Could you just choose between substitution or elimination, or do you use one for or each for like different situations?
This one it's easier to elimination because the A values will always be single based on the formula. Right?
Mr. Kim, I have to go now.
Okay.
Thank you.
Check the video if you need to. The next part is exactly the same, but we're doing division and multiplication. That's all.
Okay, thank you.
Okay. See you later. So you see it? The formula has an A value already all alone, isolated. And so if you do elimination, you can just automatically subtract them and they become 0. It just makes life easy. So I would recommend elimination instead of substitution. Any questions? Yeah, I don't think so. You just gotta practice it. And again, more exposure means more awareness of what kind of questions I could throw at you. And that's all it really is. If we were in a normal term, now would be when I stop the lesson, get you to try to, practice some textbook questions and have an easy day. But because we're in a quadmester, I'm gonna sort of push you. I'm going to do the exact same style of questions, but for something called geometric sequence. So the sequence simply means, again, a set of numbers separated by commas. But geometric, I don't add something or subtract something to get to the next number. Instead, I'm doing the other, other operation, that's what I'm looking for, which is multiplication. So take a look. Please go back to, go to the next page that I have set up for you, and that is geometric sequence. If the question refers to geometric sequence, I am not adding or subtracting, I am multiplying. We are dealing with not D, but an R, a common ratio. So again, if you missed the lesson, you can read this, right, to get a better idea of what's happening. The equation that I'm going to be dealing with is this, and instead of getting you to memorize, I'm going to show you why an exponential makes sense in this situation. Come along with me. I'm going to try to identify all the different factors here. This is still the same. The A value is a 3. However, what did I do to get to the next term in this sequence? I think you can guess.
Multiply by 4.
Yeah, times 4, times 4, times 4, times 4. So let's pretend we knew nothing about how to do patterns. The first term is a 3. The second term is a 3 times 4. The third term is a 3 times 4 times 4, or 3 times 4 squared. T4 is 3 times 4 times 4 times 4, or 3 times 4 to the 3. Am I being obnoxious? You guys get it? So if you think about it, again, term, exponent of 1. Term is 3, the exponent is 2. Term is a 4, exponent is 3. Term is a 5, exponent is a 4. So whatever the term number is, I had to multiply the ratio 1 less than the term number. So 4 times 4, 4 squared, right? So if you take a look at the sequence, you see that this is what's constantly being multiplied. If I want to write this efficiently, the general term is whatever number we start with, so in this case it's a 3, multiplied by whatever the ratio happens to be, but I multiply it just 1 less than what the term number is. That's where the formula comes from. I think we established it for this one. The Tn, the first number is a 3, the common ratio is a 4, n minus 1. There it is. The question also asks you for the 10th term. So T10 equals 3, 4 to the power of 9, which is a pretty big number. Where is it? Where's my calculator again? 3 times 4 to the power of 9. 786,432. How is that? Well, it seems straightforward enough, but you're going to have to try it and apply it yourself. So I'm going to give you about a minute. Could you try doing this? And just to get you into the right direction, remember, choose whatever, for the ratio, what you can do is choose whatever number you want. Let's do negative 40 divided by 27. I'm not going to subtract the 20 over 9. If you want a ratio, if you want to see what I multiplied, the reverse of that is divide. If you chose negative 40 over 27, divide by the previous term to see what the ratio is. Let's see what you got. I'll give you a minute. Okay, assuming you gave yourself a chance, When you're doing a ratio, again, I hope you remember, if there's one thing you're going to take home from this class, dividing fractions, same as multiplying the reciprocal. So let's simplify. The common ratio between these terms is multiplying by a negative 2 over 3. So you might notice that the numbers are getting smaller and smaller and smaller, or the absolute value. The a value is also a 5. So the general term of a geometric sequence is 5, negative 2 over 3, and minus 1. All that's left is to plug in the n value of 10, which gives me that. And don't be afraid of big numbers. 2 to the power of 9 times 5. That's a negative 2560 divided by 19,683. Okay? So you can see it's the same thing. If it says arithmetic, we're doing a subtraction between the terms to see what the difference is. If it's geometric, you're doing a division of sequential numbers to see what the ratio is. The same applies for that question when we did the elimination substitution. For elimination, we did subtraction because the difference is usually an addition of something. In this case, because a ratio involves a multiplication, to find the R value, you're going to be dividing things. Let me show you what that looks like in action. Number 2 and number 3, and then we're done the lesson for today. Determine the number of terms. Once again, I want to know what the n value is. In a geometric sequence, which means I'm dealing with R, they give you the first term. That's nice of them. And using this, we can figure out what R is. I want to know what n value is. I want to know what term that's going to be. All right, so let's hash out what we do know about this question. A is a 5. The R value is 20 divided by negative 10, which is negative 2. Again, you could have chosen any number, okay? If you did a negative 40 divided by 20 still gives you a negative 2. Tn is equal to 5 times negative 2 to the power of n minus 1. Okay, that's the first half of the question. Next, if I know the final number is going to be 1,280, well, what is the n value that gets me there? You notice? Do you remember some of these kinds of questions? I didn't teach you how to find the value of an exponent. You don't know logarithms yet. And so the best you can do is do some guess and checking. I'm going to divide both sides by 5 so that I get this exponent all alone. This becomes 2, 5, 6. Great. And now you might recognize the number 256. Negative 2 to the power of what gives me 256? You might be a little thrown off by that negative, but if a negative base gives you a positive value, it simply means that there is an even number of multiplications. The number for x is 8. Negative 2 to the power of 8 gives you positive 256. This means, therefore, 8 must be the same as n minus 1, and so n must be 9. There are 9 terms in this sequence. How's everyone? Now's a good time to ask any questions because I only have one more example for you before you can, you know, request some more or go straight to the textbook or go to the problem set.
Do we learn logarithms in grade 12?
You do. If you got a chance to do it in chemistry, I mean, you're totally welcome to use it, but I won't expect you to be able to do it. Like, you don't need to feel like you're going to be tested on it. Everything that I give you will be at a level where you could guess and check, just like our exponent unit. Okay. All right. Let's do this. The final question is very similar to our arithmetic sequence, where I give you two sparsed out terms, and I ask you for another one later on. So T3 is 12, and T6 is negative 96. I'm asking you to find me what T9 is. So the easiest way is to figure out what the A value could be, what the R value could be, because n minus 1 will end up being just to the power of 8. Okay, so let's hunt it down. Method number 1, it is using logic. We can use logic here. So again, t to the term 6. To go from term 3 to term 6, how many times did I multiply the R value? 1. So this would be term 4, term 5, and that would be term 6. So putting this together, negative 96 is equal to 12 times R cubed. Then again, I get R all alone by dividing both sides by 12. I get negative 8. And what is negative 8 in terms of a power of 3? Well, that's the same as negative 2 to the power of 3. R must be negative 2. And from there, again, we found our R. So let me highlight that so that we can celebrate. We found our R, so we found this portion. All that's left is the A, and we will do so by plugging into any of these terms. Term 2, which is 12, is equal to AR squared. Remember, term 3, n minus 1. So if 12 is equal to AR squared, it's the same as negative 2 squared. 12 is equal to A times 4, and A therefore must be a 3. And again, yay celebration, we found our A value. As a final step, what is T9? That is 3 times negative 2 to the power of 8, which is times 2 to the power of 8, a positive 768. If this is okay, I know some people might still be copying. If this is okay, I'm going to show you the other more logical, so not logical, more mathematically inclined way, where you can explain using just what you know without having to necessarily rely on logic. And this is especially useful if numbers are very obscure or it's very difficult to actually identify what the R is on its own. What if it's not a negative 2? What if it's a 1 over 9 or something, right? It might be difficult to hash that out. And so here's a more foolproof way you can do it. You know that T3 is equal to 12, which is the same as AR squared. Shoot, I wanted to do that later. Okay, You also know, I put this up here for a reason, T6 is equal to negative 96, which is equal to AR to the 5. Right? So remember, this is a multiplication of values. So we can actually do some interesting things in terms of division. What I'm going to do is take away these equal signs. I'm going to divide T6 by T3. That means negative 96 divided by 12 is the same as AR to the power of 5 divided by AR to the power of 2. Okay. So I'm dividing the terms. So negative 96 divided by 12 gives me negative 8. And A divided by A is a 1. And R to the power of 5 divided by R to the power of 2. Remember exponent laws. R to the 5 divided by R to the 2 is basically 5 minus 2. It's R to the power of 3. And essentially what we have here is the exact same situation we have right there. And the rest is history. Either way you do it, whether by logic or by methodical sort of division, you should be able to sort of solve these puzzles and just sort of unpackage these questions slowly but surely. If you want to test your mettle, I basically asked you the exact same type of question here. Determine T10 if I give you term 3 and term 7. Any questions? No? I just feel like I'm constantly just talking and you just listen and regurgitate everything I say. Let me do a quick plug of where this goes, and I'm wondering if you can see it. I'm hoping you can see why I say chapter 6.4 and 5 is sort of sort of the unofficial start of the chapter, because this directly applies our knowledge into finance. You can see how arithmetic makes sense when you're saving money. Like you're saving, let's say, $200 every month. So plus $200, plus $200, plus $200. If I do that for 30 years, how much do I finish with? Sort of like that. And then for geometric, I hope you sort of see it. Instead of saving money, let's say I have like $1,000, and then the bank gives me an interest of 1% every year. So I get 1 year, and then the next year, and then the next year. If I wait 30 years, what does my money grow into? Right? Like I'm hoping you're starting to see that there is a connection between what we're doing here and the financial math you'll do in the future. Okay? Well, that's my hope. Before we move on, again, and rather not move on, but before I dismiss you, because I'm basically done, the rest is up to you to do homework, and I assigned a whole bunch on our handout. I want to, again, get you to remember or get you to recognize keywords which will dictate how you're going to approach a question. Very important. I'm going to remind you again about the quest that you have to do by tomorrow midnight. And all the other assignments, if you aren't done it, that's already late, please get it in by the end of the weekend. Any last questions before I take over? No questions about the lesson or the quest or assignments?
I have a question.
Yes.
It's like kind of far back though. It's like
Okay.
there's a question about question 1B of geometric sequence.
Okay.
And I missed how you got the final answer. I stopped at, it was T10 equals 5 times negative 2 over 3 to the power of 9.
Oh, right. So T9 is 5 times negative 2 over 3 to the power of 9. So what I'm doing is literally negative 2 over 3 times negative 2 over 3 times negative 2 over 3. This is essentially, the easiest way is, let's pretend, negative 2 is being to the power of 9, and the 3 is to the power of 9. So you get 256 times 2, a negative 512 over 19,000 something something something.
And then you just multiply both those by 5.
Yes, the numerator, so it's basically 5 over 1. So numerator times numerator, 2560, and then 19683. Okay?
So for types of questions then, if
Ready?
your D value,
Yep.
your R value is a fraction, does
Uh-huh.
your final answer have to be a fraction?
No, but this is more exact than anything else, I think.
Yeah.
If you did it at decimal, it'd be 0.1300614. It's inaccurate or not precise. Okay? All right. Let me bring your attention to our calendar. And I want to just justify and explain why I'm rushing you a little bit. This is more for your own good, not for me. I hope everyone can see our calendar. And go all the way down to where we are. We are right here. We are on a Wednesday, Thursday, right? The problem set with the binomial expansion is already out, and we just finished arithmetic geometric sequence. From tomorrow, when I see you in the mornings, a Monday and Friday, we're finishing off chapter 6, at which point I give you another problem set that specifically or focuses on chapter the sequences and this thing called the series. But after that, take a look at what's left. Once you get problem set for chapter 6 worth about 20 marks, we have a 4-day weekend and then another 4-day weekend. And surprise, you're done the course. We have 2 weeks left together. And those weeks are short weeks, they're 4-day weeks. Right? After the March break, there's a flex day, and then there's a whole bunch of credit rescue periods. I don't think there's going to be anything covered. I'll update you later on, but I don't know if there's going to be class here. I think there is, but again, I'll tell you later. Up until now, I gave you a lot of assignments. There was an optional assignment, there's a 5-mark Desmos assignment, and then there was a big quest that I got you to do over this entire week. And while that's happening, there's a small problem set that you probably should be able to finish tonight. And then another problem set. I know that's a lot. But once that's done, we basically have nothing else this week except for the problem set. And long weekend. And then afterwards, I'm still debating and fighting with myself whether I should give you a chapter 6-7 quest because the problem set covers everything I want to for chapter 6. So this quest will be focused on chapter 7. But the optional mortgage future retirement assignment is basically what I would have given you for chapter 7 quest anyways. So I don't know if I should give you a quest and then an optional or just make this assignment mandatory. I don't know. So the main problem with that is I don't have the ability to, so as a teacher, I am sort of forced to make all deadlines by Friday. I can't make any deadlines on Monday after the March break because by policy, it is very, very, very discouraged to make any deadlines after a long break like this so that students can actually enjoy their break, right? So is like 3 days enough to finish this big retirement, planning assignment? I don't know. So if the due date is Friday, then then it's going to be optional. It gets really confusing. And so I'm still figuring out what I want to do. I will keep you updated, but that's our forecast. We have, after tomorrow, 2 weeks left. All right? So half of it is congratulations, you basically made it to the end of this course. Pat yourself on the back, and away we go. But the other half is because it's coming to a close. That's why I'm pushing everyone to get things done earlier than later. Stop leaving it to last minute. Can we vote? I'm going to use my authority in this classroom, and I'll figure it out. I'll decide what I want to do with it. I'm not quite sure. Okay, so sorry, Claire, but I'll make the final decision. Yeah, and then from there, I'll share a couple of things at the very end of the class as an outlook. But that is where we are. Okay, so it's really soon. So don't think you have a lot of time. We're almost there. Okay? Any questions?